Radhe Radhe. So in this video, I'm going to discuss today's Leetcode challenge, like all the 4 problems. So if you have any doubt regarding these problems, you can ping me up on Instagram. Even you can join my Discord server. I will provide both the links in the comment section. I'll pin them. So let's start with the first problem. The first problem is count substrings that satisfy K-Constraint part 1. Okay. So this problem was very simple. Like if you don't get it, let me just explain the question. You're given a string and you have to find all the number of possible substrings where the number of 0 is at most k and the number of 1 is at most k. Sorry, not and. It's going to be either number of zeros is at most k or number of ones is at most k. So it's basically normal logic. Like you can do one thing, just fix the first position. Okay, let me do this. So you can, like, let's say you have an array. Okay, in that array you have some elements like this. Okay, so you can traverse throughout the whole array. That is, you can make for I from 0 to I less than n, I plus plus. Okay, you can make this, and after you're done with this, like inside this, you can start from every element. That is for j is equal to 0 to n, like j less than n, j plus plus. Okay, and for every of the elements, you're going to count the number of ones. Sorry, j starts from I. Okay, because like you're going to fix the starting point, and for every possible elements, for every possible starting point, you're going to check how many such substrings are present. Okay, so you're going to keep a track of ones and zeros. Okay, now if ar of if ar of j is equal to 1, so 1 plus plus else this. Okay, and before this you can do one thing. You can make ones as 0 and zeros as 0 2. Okay, now if at any position you can find that ones is lesser than equal to k or zeros is lesser than equal to k, you can simply say that result plus plus. Clear? I hope this is clear, right? So you can directly make result plus plus, and after that you can simply return the result. Okay, so what we did, we are going to traverse over the whole array, and we are going to fix, let's say for this, sorry, so there are a few positions. Okay, so we are going to fix this position and start from this position till the end. Then we are going to fix this position and start from this to here. So basically if we do this, so we are going to consider all the sub arrays. Okay, you're going to consider all the sub arrays that has, I mean, sub arrays or substrings, whatever it is, you are going to consider all of them, right? So using this you can like go for the result. So let me give you a dry run. So it will be better if I can give you a dry run for this. Okay, 1 0 1 0 1 0 1. So let me write it, 1 0 1 0 1 0 1. So when you're traversing, okay, so let me give I, the values of I as 0 1 2 dot dot dot. Okay, for now, just the time being. So when I is equal to 0, so you're going to start from here, right? So over here you can see that ones is, there is 1. Okay, so ones plus plus. So let's say ones is equal to 0 and zeros is equal to 0 initially. Okay, and over here you see that ones becomes 1. Is either of them lesser than equal to 2? Okay, so k was equal to 2. K was equal to 2. Is either of them lesser than equal to 2? Yes. So you have to consider this. So result was 0. Now it's 1. Now you go to this. It is still, both of them are lesser than that. So 2. Then go to this. So both of them are lesser than that. So now go to 3. And you can you can just continue. Okay, and once you're done with this, then you're going to consider this. Okay, then you're going to traverse from here to throughout the whole. Then you're going to consider this, then traverse from here to whole, and thus you get the answer. Okay, so basically it's going to be 25. So like if you don't get it, let me tell you why. Because it can be maximum 2, right? So for this is the value, this is the string, maximum string. So this is the maximum string. For this is the maximum string, and for this is the maximum string. Okay, so I made a mistake. Okay, so this is not going to be this. Okay, so let me rewrite it. 1 0 1 0 1 0 1. So for this whole thing is going to the maximum string, right? Because after this comes over here, then it's the only problem that we face. For this whole thing is the maximum string, and for this for this whole thing is the maximum string. Okay, and for this, for all of the rest, it's going to be this and this. So if we check for all the starting points over here, you can see that there are how many? There are 1 2 3 4, right? So sorry, 1 2 3 4 5, right? So answer, result, it is 5 for this. Then it is also 5 for this, so that becomes 10, and then again 5 for this, that becomes 15. Okay, then there is 4 for this. Okay, so if it's 4 for this, so it becomes 19, then 3 for that, 9 10 12, 9 10 11 12, so 22, and then 2 for this, so that is basically 24, and then 1 for this, that is 25. So I hope this is clear for you. So if this is clear, we can go to the next question. Okay, so this is problem B, where it is given as maximum energy boost from 2 drinks. Okay, this problem, so you're given 2 types of drinks and you get this amount of energy whenever you drink one of them. So what you can do is, for every hour you can drink any of the drinks, but if you're drinking this drink, so for the previous hour you can either drink this but not this. Okay, so like it's like you're going to consider from the beginning. Okay, so if you drink A, and the next hour you can drink A, and if you don't drink A in the next hour, then only you can drink B in the next hour. Okay, so it's like if you are switching from one drink to other, so you have to give a gap of 1 hour so that your immune system or whatever it was given in the question. Okay, so I think it's very much natural to get the, like we can say directly that it's a DP problem, as a dynamic programming. So you're given 2 arrays. So let me give you like what the recursive relation looks like. It will be dp of A. So dp of A of I is equal to A of I plus whichever is going to be the maximum. Okay, maximum of dpa of I minus 1 or dpb of I minus 2. Similarly for dpb also, it is going to be like this. dpb of I is equal to b of I plus maximum of dp b of I minus 1 comma dp a of I minus 2, right? Clear? Why is it so? Because whenever you're drinking one drink, so it may happen that you have drank the previous drink of the same category, or you have skipped the previous hour for every drink and drank the previous to previous drink of the other category. Okay, so this is what the recursive relation looks like. Now there's some few like basic concepts that I hope I'm explaining thinking that you're just a beginner. So that is I minus 1, you have to check if it's inside the limits or not, and I minus 2 also you have to check whether it's inside the limit. So basically this you can do if I minus 2 is greater than equal to 0, and if I minus 1 is greater than equal to 0. Okay, else if, so you can at that moment you can just eliminate this. Okay, eliminate this, and else if I is greater than 0, that is basically, okay, like let me not write it like this. Okay, so let's say I is greater than equal to 2. Okay, then you're going to consider everything, the whole code. But if I is greater than equal to 1, but it is lesser than equal to 2, I mean it's lesser than 2, and there is another concept where this is the concept. Okay, so for this consider all of them. For this, don't consider this, that I minus 2 things. Okay, and for this, just consider the a of I, that is, don't consider this whole thing only. Okay, so this is basic thing. Okay, this is just to check for the array out of bounds. Okay, array out of bounds. I hope this is very much clear. So basically this was the recursive approach, recursive equation or relation, whatever we may say, for the whole question. I hope this is clear. So if you, in case you want a dry run, so let me do it with the last one. So it is going to be 4 1 1, and it's going to be 1 1 3, right? Now, so let me write what dpa looks like and dpb looks like. Okay, dash dash dash, for like in the beginning, dash dash dash. Okay, so as I mentioned that if I is in this range, just go for a of I, b of I. So that is 4 and 1. Okay, 4 and 1. At this stage, this condition satisfies. So you are not going to consider dpb. Okay, just consider the same element. That is, just add the previous element with the present element. That is 1 plus 4. That is 5, right? And then 1 plus 1. That is 2. Okay, clear. Now this, for this element, you can either add 5 or 1. So which is better to add, 5 or 1? 5 is maximum, so you're going to add 5 to 1, right? That is becomes 6. And for this also, you can either add 2 or 4. So 4 is maximum, so you can add 4 to 3. That is 4 5 6 7, 7, right? Now you can see that throughout the whole, like the last positions, the whole array is, considering both of them, the maximum element is 7. So you get the answer 7. I hope this is clear now. So we can go to the next problem. So the third problem basically is find the largest palindrome which is divisible by k. So let me give you the slight hint of the problem. You have to find the largest digit of containing n digit number, the largest n digit number which is divisible by k. Okay, but the trick over here, you can't recursively, like you can't use the iteration. Okay, because you can't check from, because the range of n is like large enough, so you can't use it. So you basically need to have some of the basic approaches, some basic logical approaches. Okay, so let me like give you a table. Okay, so what is the value of k? The value of k was, it is given that it would be from 1 to 9. Okay, so you have a value of k and a value of n. Okay, so let me like write the k over here and the n over here, because I won't need much for the n. Okay, so k can be 1 2 3 4 5 6 7 8 9. Clear? Just let me make the table as quick as possible. Like if you have problem regarding this, you can even make this table so that your understanding becomes much more clear. Okay, so for n there are few conditions. Okay, if n is equal to 1, if n is equal to 2, and if it is greater than 2. Okay, now if n is equal to 1, we can say that for all the elements it is going to be 1 2 3, since all the elements are of one digit. So largest palindromic length of that which divides that thing is basically whatever k is, the value of k. Okay, so you can just print them. For 2 also, what we can do is, you can, like for this 1 1, you can go with 99. For 2 2, you can go with 88. For 3, again 99. For 4, 88. For 5, 55. For 6, 66. For 7, 77. For 8, 88. For 9, 99. Right? Now these conditions are what mainly matters for us right now. Now, if you notice one thing, that whenever you're going to consider 1, so any element is divisible by 1. So we can just, in spite of doing this, so I made a mistake which nobody of you noticed. I hope many of you have noticed. So like, okay, so this is basically, this can be 9. Okay, this can be 9, this can be 8, this can be 9, this can be 8, this has to be 5, this has to be 6, this has to be 7, 8 and 9. So like, I purposely made that mistake because you need to understand one thing, that 1, 2, 3 and 4, since these elements are lesser than 5, that is the half. Okay, since these are lesser than 5, so you can modify this. And if you notice one thing very carefully, this 8 is repeated, this 8 is repeated, this 9 is repeated, 9 is repeated. So first let me give you a basic approach for 1, 2, 3, 4. Okay, so for 1 you can just print all the 9s, and for 3 also you can print all the 9s. Okay, for 2 you can print all the 9s except the last and the first element is going to be 8. Okay, so because that is the best approach. Okay, that is the most greedy approach to do this. Now for 4 it is similar to this. Okay, other than everything is going to be 9 except the last 2 elements. Okay, everything is going to be 9 except the last 2 elements and the first 2 elements, which is going to be 8, because the divisibility test of 4 is that the last 2 elements should be divisible by 8. 4, right? And this is the reason why we did this separately for 2. Okay, so basically this is going to be over here and this is going to be over here. The remaining stays as it is. Now similarly you can say that for 8 also we can do this, right? We can do this, we can make this. So yeah, we can make this 888 with how much 9 is it over here, and then 888. Okay, I hope this is clear right now, right? So we have solved for 1, 2, 3, 4, 8, and for 5. Okay, let me like solve it for 5 also. For 5 you have to make the first element 5, last element 5, the remaining remains 9. Okay, so we have solved for 5 also. For 9 it is similar as 1 and 3. It is going to be all the elements is 9, because 9 divides all the elements. Like, it is all the elements are 9, so it divides it, right? Now we are left with 6 and 7. Okay, so like, let me write it differently for 6 and 7. So for 6, 6 is basically 2 into 3. Okay, now since 6 is 2 into 3, so we can say that the last element for 6 has to be an even number. So what is the best approach? We can make all of them 9 except the last and this element. Okay, so now this becomes divisible by 2, but this doesn't mean that it is divisible by 3 also. Okay, now for this divisibility of 3 along with 2, there are 2 conditions. Okay, one is n is even, other is n is odd. Okay, so we can say that over here, initially the number, the divisibility test of 3, it is that basically the sum of all the digits is divisible by 3. Now initially if we would have made it 9 and 9, okay, so it was divisible by 3. Now we have removed 2. So how much do we need to remove more? We have to remove 1 more, right? So what we can do is, we can just make the middle element as 8. Okay, but this is only possible when n is odd, because if n is even, there will be 2 middle elements, right? So if n is odd, middle element 8 and the extreme elements are 8, right? Clear. But if n is even, so you have to change both the middle elements. Now the trick is, since like you can just subtract 1 from here, or you can even subtract 1 plus 3 from here, that is 4. So if you're subtracting 4, that means for the 2 elements, for the 2 middle elements, you're going to subtract 2 from each, right? So it is going to be 8, 9, 9, 9, 9, 9, 9, 8, and then middle 2 elements is going to be 7, 7. Okay, so what we basically do is we can either make the middle two elements 7 7 if n is even, and if n is odd, just change the middle element as 8. Okay, clear? So we are done with 6 also. Now this 7 thing, you have to understand one thing. Okay, I think I'm short of spaces, so like let me take out a little bit of page from here. Okay, so for 7, let me write it. So if you know about the divisibility test of 7, like there's a shortcut over here. Okay, so what is the shortcut? You can divide the whole number into groups of 3. Okay, groups of 3, and you can add this. You can add this, subtract this, add this, subtract this, and so on. Okay, and after that you can like come to a conclusion that if this number is divisible by 7, then you can be assured that the whole number is divisible by 7. Okay, now what is the basic thing this demands is how many, like let's say we have a n digit number of 999. Okay, n digit number. So the first element is 9. So just to make the whole number of digits divisible by 3, we can either add 1 0 or we can add 2 zeros, right? Now, if we are checking it for just this element, okay, so let's say there is 999. Okay, so if we group them, it is basically 0, right? So it is divisible by 7. We can see directly. So this is a good approach. But what if there was an extra 9 over here? So there would be 009, right? Because we would be adding 2 zeros. Okay, so then that would be 009. Now there is an extra 009. That is, there is an extra 9 over here. So how can we eliminate that 9? Okay, so we can eliminate that 9 by changing this element. Okay, by changing this element. So what should be the value of this element? So let me say that this element is going to be x. Okay, so basically 009 plus 999. Okay, so that makes it, I think, 81008, and there is this 99x. Okay, so basically 99x is equal to 1008, right? You have to go with this. But there is also another situation that this can be like what to say, like this can be a divisible. So like this element, when you subtract them, it should be divisible by 7. Okay, so if we are going to subtract 7 from 1008, it becomes 1001, right? Again, if we subtract 7, so now it becomes 994, right? So it becomes 994. So if we replace x with 4, we can say that this satisfies, right? And let's say if there was only 1 0 over here, right? If there was 1 0 over here, so in case of 1 0, there was 99. So it's going to be 99, then 999, whatever it is. Okay, it doesn't matter for now. So 999, some of the 9, basically I'm not considering the rest of the 99s because they're going to get cancelled out, because we are just subtracting and adding at alternative points, so they'll just get cancelled out. Just take the first 3 elements. Okay, so 999 and then 099. Okay, now if we add it, there's a twist over here. Okay, now it's becoming 1098, right? Now since it is becoming 1098, we can go for 99x. Okay, we can go for 99x and check what is the value of x should be. You can check the value of x, just similar to this one. So I hope this is very much clear that how we are going to find the value of x, right? Now you may come with an approach that calculating the value of x is really difficult for us. So since we know that the value of x ranges from 0 to 9, because it is just one digit, so we can do a brute force by replacing the value of x with 0 to 9, in the original array and just check whether it is divisible by 7 or not using this logic. Okay, using this logic, just check it. So if it's divisible, you can just see that it's divisible, and if it's not, go on to the next element. Okay, so you have to start from 9. So basically now let me come to the fresh page, like this page. So you have to start from 9, go on till 0, and let's say you have 9 9 this 99 x 99, right? Because you can change only this element, right? So you're going to like put every possible element from 9 to 0, 9 back to 0 over x, and check if it is divisible by 7. If it's divisible by 7, just return it. Okay, clear? Now how you're going to check it? We are like, obviously this is string, so we can't check it. So we are going to check it using this, that the consecutive, the alternatively, if you add and minus, add and subtract, if it's divisible by 7, you can go for it. Okay, clear? I hope this is clear. But there is another situation. What if this is when n is odd, right? N is odd. Now what if n is even, right? So this is the last situation where n is even. So when n is even, there is also a better solution over here. Okay, so what is it? So we can like 999 and then 999, and there is x over here, right? These two are the middle elements. So the same thing happens, just in spite of writing the x in the middle, you're going to write x in the two middle elements. Okay, and then check for all of them. So I hope this is clear. So that's how you're going to make it, how you're going to do this. And if you can like calculate the value of x using the formulas that I have given, it's good, you can go for it. But I think this is much more complex, and since the time constraints, I mean the time, the constants of the values and the time complexity according to that is not of much of a issue, so you can just simply go for brute force. So that's it for the third question. So I think if this is clear, we can go to the next question, right? So now finally the last question, that is count substring that satisfy K-constraint part 2, which is the last question of Leetcode. So this is a problem, I think, which very few submissions were there. So if you look into the question, it is similar to the first problem. Just the fact is that for the first problem you were considering the whole string, but now you're going to consider this just a substring for all the queries. And within this substring, you have to find all the substrings which satisfy that condition. Okay, so I won't explain what the problem is basically about. I will just go for the solution, because I hope this is clear. Like basically, okay, let me explain it. So you're given a substring, and for every queries you're going to consider a substring, and within that substring you have to find the count of substrings for which either the number of zeros is lesser than equal to k, or the number of ones is lesser than equal to k. Okay, clear? So for this you can say that it's going to be 26. Why is it so? Because 0 0. Okay, like for now let me just directly jump to the solution, and after that I will explain how I'm going to solve it using the solution, and what is the answer of it using brute force. Okay, so initially over here we are going to fix something, right? We have to fix something. So either you can fix the end or you can fix the beginning, but I will prefer fixing the end. Okay, fixing the end of the subarray, I mean substring. Okay, substring. Now what you can see is like you can store the values like number of ones from the beginning till that position in an array called ones. Okay, so this is basically prefix of ones, okay, of size n, and there is prefix of zeros of size n2. Okay, n, okay, both are of size n. Now you can solve like this, you can get it. Now you have to use some dp. Okay, so what basically the dp is going to do is, you have to like whenever you're going to traverse, okay, from I is equal to 0 to n, I less than n, I plus plus, okay. So whenever you're traversing throughout it, so you know the number of ones and number of zeros, okay, very much clear. Now you can fix L as I and R as n minus 1, okay, or you can fix L as 0 and R as I. So whatever I told you basically, like you can either fix the end or you can fix the beginning. But since like I'm going to teach you using fixing the end. Okay. Now when you're fixing the end, so you can check for all the elements for L lesser than equal to R, that is you're going to perform a binary search. Okay. Perform a binary search and find the element for which, like if you're starting from here, so what is the first element till which you can see that this is a valid substring. Okay, how we are going to make this? We like the number of ones is basically P of ones R. I mean, like R doesn't mean that this L and R. Okay, so like let me write it. Right minus PR0, PR1 of left minus 1, right? Since this is going to be like the number of prefix, you know how to like extract the number of ones in a specific range from the prefix of ones, you know this, right? So this is basically the formula for this. Now you have to check for the number of ones at mid position, you have to check for the number of ones, you have to check for the number of zeros. If both of them satisfies, you can just simply write dp of I as mid. What is mid? Mid is the position, the leftmost position where this satisfies. Okay, and when you're making this, you can like go for the necessary ones, that is R equal to mid minus 1 or L is equal to mid plus 1 if this is not so. Okay, so you have got the dp, that is what is the leftist most element which satisfies a substring ending at over here. Now comes the query part. Okay, so before using the query part, you can also have a second dp array which we can say that it is going to be sum. So the vector sum is also of size n. What it is going to do is, it is basically for all the dp's, it is going to like let's say if I have a dp, okay, for dp at position R, the leftmost position is L, okay, L1 and R1, let me name it for lesser ambiguity. So for dp, so this is R1 and L1, right? So how many possible substrings that can we make if we fix the position at this? It is going to be R1 minus L1, right? I mean R1 minus L1 plus 1 actually, because like the number of substrings, you know the formula, like if you are going to fix it. So basically you can choose any element from L1 to R1 for the starting point. Clear? So this thing is going to be stored in the sum. And sum doesn't only store this, but it also like stores whatever was the previous one. Okay, so what is sum basically storing is, sum is basically storing the sum of all the elements from that position till all the positions before that, and the number of substrings, number of valid substrings that they have. Okay, so basically you can use a recursive function for sum as sum of I is equal to, I mean sum of I plus is equal sum of I is equal to sum of I minus 1 plus this value. Okay, R1 minus L1 plus 1. So what is R1, what is L1? R1 is basically I, L1 is basically dp of I. Okay, so sum of I is equal to sum of I minus 1 plus I minus dp of I plus 1. Okay, clear? Now we are going to go for the queries. Okay, for the queries, for every query you're going to get a li and ri. Okay, now let's say the sum, the dp thing looks like somewhat like this. Okay, now L1, like there are other elements of the dp also over here and here, but L1 is over here and R1 is over here. Okay, these two the positions, and all the elements between these are the dp elements. Okay, like everything is the dp, this is the whole dp array or the vector as you may say it. So between them, you know one thing, that if we are going to consider R1 as the end point, okay, R1 as the end point, so you have to find the leftmost element. If the leftmost element lies between this L1 and R1, you can consider all of them. But if it is lying before this, so you can consider only till L1. right? So if this, let's say if this element, there is an element, this over here, okay, this is an element over here. If this element is having its leftmost point towards the left of L1, that means if there's an element before that, it will also have an element before this, right? It can't have an element before, like over here, because if this satisfies till here, so this will satisfy either till here or before that. Okay, so this is the basic logical thing. I hope this is very much clear with you. So once you're done with this, so you can store the sum of all of them using the constant that if any element is having its value towards the left of that, you can take it till L1. So that is dp of I is maximum of dp of I comma li. Okay, but we can't like go on changing the dp of I for all the elements in this range, because we know the time constants are there in hand. Okay, so what we can do is, since we know the sum of all the elements, so we can sum it up for all the elements, but there are some few elements which are going to give us the trouble. Again, we are going to use binary search. Okay, so again we are short of pages, so I'll be taking out this page for now, and let me write it. So basically you're going to find a binary search. Okay, so from Li to Ri, you have to find the position of the rightmost element whose dp of I comes before L of I, the rightmost element. So you know that dp of I, if this is coming before this, so the dp of I plus 1, it should be always greater than equal to Li, right? It should be always greater than equal to Li. So for till dp of I plus 1, so from dp of I plus 1 to dp dp of Ri, this situation is nice, right? Okay, we can just simply add them for right now, not the dp thing. Okay, you know that whenever talking about adding, that is a sum thing. So we can just check the sum, like from I plus 1 to Ri. Okay, we can just check the sum, but for the remaining elements you have to make the leftmost limit as Li. Okay, so let's say there are few elements over here and this is Li. So what is this going to be? It is going to be 1, it is going to be 2, it is going to be 3, right? And the remaining elements are going to be summed as it is. Okay, because I was over here. Okay, now here's a pattern, that is 1 2 3. This pattern, this is basically n into n plus 1 by 2, right? So what we can do is, we can find the I using the binary search. So basically we can find the value of I using the binary search. Okay, and once you have found the value of I, you can like the sum, the answer, okay, answer of I is becoming sum of R minus sum of I minus 1 plus n into n plus 1 by 2, or let's say m into m plus 1 by 2. Okay, so what is m? M is basically the number of elements from here to here. So you can notice one thing, that if this is the element over here till which we are going to consider, okay, so how many are going to be add? What is the value of m for now? So let's say, what is the difference of these two values? It is going to be 4, right? So we can say I minus L of I minus 1. Okay, I minus L of I minus 1, and then just go for the summation. Okay, I hope this is very much clear, like why we are doing this. So basically I think it will be better if I can solve it using something like, I can solve it in a fresh page. Okay, so let me take this example, that is the string is 0 1 0 1 0 1, k is 1, and these are the these are the queries, and this is the output. Okay, so how we are going to do this? So like I'm not explaining the ones and zeros thing. Okay, because I think this is that was very much clear for you guys. So I'm just explaining the DP and sum thing. Okay, DP and sum, how the DP and sum would look like. So for the DP, so there is 1 2 3 4 5 6, like 6 elements. 1 2 3 4 5 6, right? So how the DP should look like, if you're starting from here, you can go on till here only, right? So this is going to be 0, because 0 comma 0 it satisfies. Now if you're going to start from 1, is 0 comma 1 satisfying? Yeah, it is satisfying, right? So you can go with 0. This is also satisfying, right? So you can go with 0 over here too. But this, if we consider the whole thing, it is not satisfying, because both 0 and 1 is having a count of 2, which is greater than 1. So you are going to just consider till here, that is till 1. Now it is going to be 1, right? For this also, it is going to be 2. And for this, it is going to be 3. Okay, so this is what the DP looks like. Now let me go for the sum. There are 1, 2, 3, 4, 5, 6, right? 6 elements. Now sum of 0 is basically DP of 0. Done with this. Now for the next element, you're going to add this 0 to this I minus DP. I hope you remember what I told you, the value. That is I minus DP of I plus 1, right? So what is I minus DP of I? I minus DP of I is this minus this, that is 1, right? 1 plus 1, that is going to be 2. Now you may say that why is it 2? Okay, before telling that, like I made a mistake over here. Okay, I'm so sorry for this. Sum of 1 2 3 1 2 3 4 5 6, right? So sum, initially sum of 0 is not 0. Okay, it is going to be 1. Okay, and that was my mistake. Okay, and so again, like we're going to check for this I minus DP of I plus 1. So that is I is 1, 1 minus DP of I, that is 1, plus 1, that is 2, and we are going to add 2 to 1, so that becomes 3, right? For this, it is 2, 2 minus 0, that is 2, plus 1, that is 3, then we are going to add 3 to this, that is 6. Now for this 3 minus 1, that is 2, plus 1, that is 3, and we are going to add 3 to 6, that is 9. For 2, there is going to be 4, 2 plus 1, that is 3, 3 plus 9 is 12. For this 5, 2 plus 1, 3, 3 plus 12 is 15, right? Now from this pattern you can notice one thing, that in the first situation, that is 0 comma 5, the answer is 15 straight off, right? And if we're going to consider 0 comma 5, so that is the sum of all the elements, so that is the answer is 15 already. So we can get a sense that we are going on the right path till now. Okay, so let's now go for the queries. Okay, for every queries we have to check. Now for 0 comma 5, okay, for 0 comma 5, you have to perform a binary search on DP from 0 to 5, okay, from 0 to 5, such that the element, the first rightmost element which is before this, right, which is before 0. So you can notice one thing, there is no element which is before 0, that is which is less than 0. So since there are no elements, we can just directly go for sum of R minus sum of L minus 1. So now since L is 0 and L minus 1 is minus 1, so there are no elements, so we can just consider this is 0 also. So basically, this is 0 also. So sum of R minus sum of L minus 1, that is 15 minus 0, right? 15 minus 0 is 15. We can go for it. Done. Now if we can consider 1 comma 4, okay, so if you're going to consider 1 comma 4, so this is this range, so let me consider 1 comma 4. Now in this range we can say that these two elements are going way before it, right? So what is the rightmost element that goes before it? This is the rightmost element that goes before it, right? So we can do one thing, we can add, we can, in spite of doing this as 0 0, I mean for these two we have to go for a special case. So till over here, so let's say this was the position of I. So what is the position of I? I is equal to 2 over here. So what I told you beforehand, we can just simply go for sum of R minus sum of I minus 1, right? I mean, sorry, sum of R minus sum of I directly, because I is the first position which doesn't satisfy it. So for these, you can consider sum of 2 and sum of 5. So that is basically 0, 1, 2, 3, 4, 5, and this was minus 1. So we can say that 5 minus 2, that is 15 minus 6. 15 minus 6 is 9. Okay, so it is 9. For now it is 9. That is 9. I'm extremely sorry. R is not 15, right? R is not 5, R is 4, right? So that is 12 minus 6. That is going to be 6, 7, 8, 9, 10, 11, 12. That is 6, right? Sorry, my mistake. So it is initially 6. Okay. So this portion we are done. And for the remaining portion, that is these two values, we are going to use 1 and 2, right? So what is n? M is 2 over here. So it is going to be 2 into 2 plus 1 by 2. That is sorry, I think I messed up my handwriting also, man. 2 into 2 plus 1 by 2. That is going to be 3, right? We are going to add 3 to this. That is going to make it 9. Okay. So you can see that the next value is 9. So if I do the last thing, I think this will be very much clear to you. So for 2 comma 3, okay, so for 2 comma 3, this situation, we can say that both the elements are way before it. Okay, both the elements are way before it. So for this thing, for the sum R minus sum I minus 1, we are going to consider nothing. Okay, because we can't consider any of them. So just blindly, we are going to write this, the M as 2. We can blindly write it. Why? Because M was, I told you, M is this minus this. Okay, the first element which is not here, that is 3. 3 minus 2 plus 1, that is 2, right? So again, 2 into 2 plus 1 by 3, by 2, so that becomes 3, right? So we can say the last element, it is 3. So I hope this is clear, like how we have done this. In case it is not clear, I'll provide you with the codes. Okay, I'll provide you with the codes. I think I will be uploading an editorial of the codes, or even I can upload the files of the codes. Like in case the codes, the links of the codes are not in the comment section, you can join the Discord server. I will provide both. I will provide the codes in that Discord server. Okay, so this is all. This is it. So I hope you got the solution of all the 4 problems of Leetcode for today's Leetcode. So that's it from my side. Happy coding. Thank you.